Yes, Prasmi, am I audible to you?
Yes, ma'am.
All right. See, we yesterday were discussing about the telescope. So let me just continue that part. And see, in the telescope, I have discussed few things with you yesterday, basic things. That whenever you have a telescope, the object length will be greater than the eyepiece, and the object will be always placed at infinity. This is what I could discuss. I remember. Yes.
Yes, ma'am.
Now see here. Here your object is put. This is the object that is present. Object is there, eyepiece is present. Now see, here the rays come. This is your objective lens. They strike up the objective lens. They intersect, and the image is formed at the focus. Reason is that object is at infinity, so of course the image will be formed at the focus of the eyepiece. This is the scenario till here. Now, what happens because you have one more lens present? So the rays of light they cross and they refract because another eyepiece is present and they enter the human eyes. As our ability of the eyes are limited to see the linear rectilinear propagation of light, so we cannot see the things that are present beyond that. So when you extend it, you see an enlarged image. So this is the enlarged image produced of a very distant object that you're able to see. Okay, so see, now you are able to see the object at least distance of distinction. The first case is when final image is formed at capital D. Capital D means least distance of distinct vision. Okay, so here the distance is D. D basically means the VE, means image of the objective lens. That is your VE. Now see, this is the focus that is formed. E is the focal length. Reason is that this part. This is reason is that there are two foci here also. The focus of the objective lens and the focus of the eyepiece. But the focus of objective lens is coinciding with V naught. Okay, V naught is getting coincided with F naught because this logic V is equal to V naught is equal to F naught. This reason. Similarly, VE is coinciding with D, which is 25 centimeter. And see, again, you have both the things. Alpha is there, you have beta. Alpha, when you see the object without the lens present, and beta is when the final image is formed. See, that's how the telescopes are used to see the distance that the images of the objects that are very distant to us. So when we say object is at infinity, this is what is meant. Okay, second is when the final image is formed at infinity. Now here I'll be applying the same thing. Let's say this is alpha, means this is alpha. You can redraw it also when you have to represent, you can redraw it also as if this is the object. Let's say this is AB present and this is subtending angle alpha, and here human eyes are present. In fact, I'll just make it exactly. This is A, B, and this is O. Okay, here this is at least distance of distant vision. This is the object that is present. Now here also when you take the ratios of all of these. Okay, here you are going to take the ratios of all of these. So magnification will still be beta by alpha. Same steps have to be followed. Magnification is beta by alpha. This is tan beta by tan alpha. This is equal to tan beta by tan alpha. Okay, tan beta by tan alpha. Now look, when we have to put in the values of this tan beta and tan alpha, look tan beta, if we calculate this beta is nothing but this A dash B, I am marking it, just see from here, this is your A point, this is the B dash. A dash B, right? It is B
Yes,
dash,
ma'am.
from the small triangle A dash B by B dash C. Talking about this alpha, see, alpha is this, but the reason is that this isn't what, that's why here also the image diagram without the lens has not been shown, because the object is at infinity. You cannot see Jupiter like this. You cannot see Mars like this, right? So reason is that because lenses are present that are making us clearly see them, the lens that are present. So here also this is located at infinity. So subtending it, the ray diagram is actually not like this in this case. That's why we don't even use this. We use this ray diagram only to mark our alpha. So what we do, we use the concept of the vertically opposite angles. That can be at least applied to get a triangle from this portion. We can extract a triangle from this portion at least with the help of the vertically opposite angles. Otherwise, drawing the object which is at infinity and getting the rays of light like this is not possible, because when the object is at infinity, the rule says, the rule of optics says that you will always have the light rays parallel to the principal axis. So this is how we are going to take this as alpha. And if this is alpha, it will be this by this. Yes or no?
Yes, ma'am.
So we can say this will be C magnification is beta by alpha. And further we can say tan beta is A dash B dash divided by this base, which is B dash E multiplied to. What is now a tan alpha? Tan alpha is A dash B dash by B dash O. This is
Mm.
OB dash divided by A dash B dash. See, these two will be cancelled. The height of the image is common in both of these. You can, in fact, one more
Yes,
thing,
ma'am.
that's getting confused in the exam. No need to take these as A dash, B dash, and all. If AB and AB dash are mentioned, you can take it as the HI, means as the height of the
Okay,
image.
ma'am.
The height of the image can also be taken, just in case if you're getting confused. But I think whatever you can name in the figure, final figure, because these figures you have to draw. Because I'm erasing
Mm.
this one also so that you don't draw this one, because that is not physically possible. No, the light rays subtending the angle like this.
Mm.
Now see, what are all these things? What is OB dash? Look carefully. If you see here, this is OB dash. That was V naught, where the image is formed from the optical center, which is V naught, or you can say F naught. Fine. That is OB dash.
Yes, ma'am.
And what is this? See, this is UE. Object, this image is actually a step, this distance that we are able to see FB dash E is actually the separation of the virtual object from the lens. This is now acting as the virtual object. There is no object present. See, if you go to trial rooms, there are multiple mirrors connected. What happens? One image is reflecting, so this image, or which was supposed to be just an image, acts as the object for the rest of the images, and that image of the first image then becomes the object for the next. Like this is how it happens when you have the reflections of mirrors or the refractions of the lenses. So here as well, this part that is present, B dash E, this part which is available, this will be your UE, because this virtual image is acting as the object, as if this was the object for this lens. Yeah.
Yes, ma'am.
So look, this will be plus F naught E, this will be minus UE. So for magnification, this will be minus F naught by UE. U is equal to the object distance is UE. Magnification is minus F naught by UE. This is D. VE is basically D. Look, if I talk about UE is there, VE is there, VE is equal to D. And object distance is equal to UE. This is equal to D, in fact minus G.
Yes, ma'am.
I just have to replace it with the length formula. I want to get the value of UE. So
Mm.
look, I think we have done it multiple times, and you also know the answer.
Yes, ma'am.
This we have done it multiple times, but anyway, see, this will be 1 by FE is equal to 1 by VE minus 1 by UE. From here, we can say 1 by VE is equal to 1 by FE plus 1 by UE if we shift it on the other side. Let's put in the values. This is, no, we want UE. I've shifted the wrong one. See, if we want UE, this will be 1 by VE minus FE. Just see, 1 by UE is there.
Yes,
It will be
ma'am.
1 by VE minus 1 by FE. This goes here, right?
Yes, ma'am.
So 1 by UE is equal to, this is minus 1 by D minus 1 by F. Also UE is negative, object distance will be negative for it in front of the lens. So same thing, look, the same thing, minus minus is getting cancelled. 1 by UE will be 1 by D plus 1 by FE if you take the same thing, right? And if you take, now you put it in the value of the formula. Or in fact, you have 1 by UE only. From here, you can take the value of 1 by UE also. But anyways, if it is F naught, let's write this is F naught, right? So from here, we get 1 by D plus 1 by F, right? That's the value. If you basically, we are replacing this value of UE in terms of this. Okay. So minus F naught is already present. We are taking, okay, here one more thing has been done. Just to tell you, FE has been taken out common. So from here, if I take FE common, 1 by FE, not FE. If I take 1 by FE common. Now 1 by FE, if I have taken common, from here 1 will be left. If
Yes, ma'am.
the same equation for 1 by UE, if I take 1 by FE common out, this 1 by FE I have taken out, only 1 will be left, plus, in order to take common from here, I have to multiply it with FE by D. See, then only, no, when you multiply, if you take something common which is not present, you have to divide it. So this is 1 by FE. When
Yes,
1 by
ma'am.
FE divides, it goes up. Look, if I
Mm.
open up the bracket, this will be 1 by FE plus 1 by D. FE will be cancelled. I hope you know this. I have told you multiple
Yes,
times
ma'am.
when you are taking common which is not present. So this is
Mm.
how 1 by UE has been obtained. Then put the value of 1 by UE here. This is the formula, minus F naught by FE, 1 plus FE by D. Clear? No sign conventions
Yes,
here.
ma'am.
This. If you are using lens formula, then definitely you'll have to put up the sign convention. But for this, you don't
Mm.
have. Okay. Now, second case is very simple. When the final image is formed at infinity. When I'll just write final images formed at infinity. This is in fact easier. All these derivations, please remember. And all the formula-based questions only come from this. Final image is formed at infinity. Now, what will be the difference? The light, the final light rays, as I tell you always in the previous parts also, these will be parallel to each other. So they become parallel. Now difference arise. Still here everything is the same like the previous part. This is your object put, this is alpha, vertically opposite, till here it's the same. And this is also the focus because the object is at infinity. This part is same, u naught is at infinity. Problem is that now v naught is also infinity. So
Yes, ma'am.
not v naught, ve. VE was D in the last case. VE is at infinity. So UE means FE. In this case, then UE will be equal to FE. UE equal to FE means object is at the focus.
Yes, ma'am.
Okay, so this will be this UE which we were taking, we are going to take it as FE. That's the difference. So plus F naught by FE we are getting. In the last case, what were we getting? F naught by UE. This will be F naught by
Mm.
FE. Okay, simply magnification will become F naught by F here minus F naught by F. This whole term of 1 plus D naught, this gets vanished. Only this part is there. Am I clear?
Yes, ma'am.
Now, if any modification comes that you should be able to handle in the sense using length
Mm.
formula, F naught, Fe, whatever. Okay?
Okay, ma'am.
Okay, please write down this part and then I'll start with prism after this. That's the last topic. Also, just do one thing. I'll have to pray. So you just text me once you are done with it so that
Okay, ma'am.
Okay.
Okay, ma'am.
Okay. See, now when we're talking about the prism, prism is the next structure. Basically, what is prism? You have glass surfaces present, and look, prism looks like as if this is a triangle prism. Prism is not actually a triangle. It is like you have three rectangular. See, it is made up of three rectangular surfaces and two triangle surfaces. So
Okay,
because
ma'am.
these three rectangles are joined like this. And this
Mm.
leftover part, one triangle here, one triangle here. Okay. So this is how
Okay, ma'am.
triangle prism looks like. Basically, these are the three rectangular face, which is known as the lateral face. These are three, and there are two bases that are present. This. So it is actually a wedge-shaped figure. Wedge. I hope you know,
Mm. Yes, ma'am.
like this. In reality, prism looks like this, but often we imagine it in the form of a pyramid. The way pyramid is present
Mm.
3D, but it is not like that. Surfaces are there, proper surfaces are inclined to each other. Now, the degree to which they are inclined to each other, this is known as the angle of prism. Okay, degree to which they
Wow.
is known as the angle of prism. In reality, this is how it looks like when the white light enters. It gets split into all of its 7 components over here. This is what the prism is. Okay, so wedge-shaped portion of transparent refractive medium bounded by two plane surfaces inclined to each other at a certain angle. Now, there's a case which is known as angle of minimum deviation, which is the most important topic of the prism. If this is done, just you can rely on the notes for the completion of ray optics. Means this is so important for. Now, understand the figure first. Trust me. See, this is the incident ray here. Okay, this is the normal because this is not a curved part. So you will have a normal reaction. I'm saying normal reaction, normal to the plane. Like this. This is the first normal. So what happens? This is air. This is prism. Material changes. Refraction will occur. So the light rays will bend over here. So this is the incident ray. This is the normal ray, and this is the refracted ray. Now, what happens because at after covering a small distance, it encounters the next lateral surface. So, as a result of which, again, this is glass and this is back to air. The medium changes, so you have the refractive index present. Okay. So, when the refractive index is there,
Okay, ma'am.
and sorry, not refractive index, you have refraction of ray of light. So it bends, and this is your refracted ray. Now, this is also normal with the normal. It is present. Now, see, this angle becomes the angle of incidence, angle between the incident ray and the normal. And this reflected ray is also known as the emergent ray. If you remember, I've talked about it in the glass lab and all. Remember?
Yes, ma'am.
So this is the angle of emergence, which is actually angle of refraction. But see, you have multiple refractions occurring. In order to tell, and I've told you earlier also, when you have multiple refractions, whether it's your glass slab or your prism, the final one with which the ray comes out, this is known as the emergent ray, and the angle is also known as the angle of emergence. So this is your final angle of emergence. Now see, few more markings about the rays. See, is the normal, this is the refracted ray. So this becomes the angle of refraction, R1. This is the R2 value, which is actually the angle of incidence for the next ray. Right? This R2 is actually the angle of incidence for the next ray. Normal,
Yes, ma'am.
because the same reflected ray acts as the incident ray. Now see, look, the ray of light, see how it was supposed to move. The ray of light, this incident ray, this was supposed to move like this if there was nothing present. Yes?
Yes, ma'am.
Now how it is moving? This is moving like this, means this is the path. Means it
Mm.
was supposed to move there, now it is moving like this. This much which you see, this is the angle of deviation. Means it was supposed to
Yes,
go
ma'am.
like this, now it is going like this. So this much gapping that has occurred, this from the plane, that is the angle of deviation. Okay?
Mhm. Yes,
Got
ma'am.
it? Now, this has a minimum condition that we'll talk later. But tell me till here, have you understood why minimum deviation, why deviation is this? This was supposed to be the
Yes,
correct
ma'am.
original path of the incident ray. And this is the deviated path. So this complete angle becomes the angle of deviation. Here we have just
Deviation.
marked angle 1 and angle 2 for the derivation. Otherwise, these are not significant. Clear? Am I clear till here?
Yes, ma'am. Yes, ma'am.
Okay, let's take this is the derivation. It is an important derivation. Please pay attention. This is angle x in this triangle. B, C, D. Now look, R1 plus R2, if we talk about plus x, R1 plus R2 plus x will be equal to 180 degree according to angle sum property.
Mm. Yes,
Okay,
ma'am.
R1 plus R2 will be equal to 180 minus x.
Yes, ma'am.
180 minus x. Okay, now look, this is a quadrilateral also. There's a property that opposite
Mm.
angles of the, do you know this property? Opposite angles of the quadrilateral are also 180 degree. That's why the
Yes.
total sum is 360. This you must be knowing. Very
Yes,
basic
ma'am.
property. Angle A plus x is also equal to 180 degree. So we can say from here, what is angle A equal to? 180 minus x. So R1 plus R2 is also equal to 180 minus x, and A is also equal to 180 minus x. What can you infer from this? From these two actually.
R1 plus R2 is equal to angle A.
Yes, very good. Angle A is actually the angle of the prism. This angle of the prism which I was referring. This one. Okay. So
Okay, ma'am.
yes, R1 plus R2 is equal to A. Means angle R1 plus angle R2 is equal to angle A. This is a very important equation also. Means you can use it directly also when needed. Now look, just see something over here. This is R1. This is angle of incidence, I. Look at this. Is this making a proper cross here? These two rays.
Yes, ma'am.
The normal and the incident ray. They are making a proper cross.
Yes, ma'am.
So this angle and this angle means the crossing one. They'll be equal to each other,
Yes, ma'am.
right?
Opposite angles. This is there's some property. Vertically opposite angles.
Vertically opposite angles. There's some property. Vertically opposite.
There is a
Okay.
property.
Yes. So R1 plus 1, this angle is equal to angle of incidence. Can I say 1 plus
Yes,
R1
ma'am.
is equal to angle of incidence? From here, I can get the value of this angle 1. Angle 1 is basically I minus R1. Yes?
Mm. Yes, ma'am.
Now tell me here what are equal to what?
Uh, the angle of emergence
Is equal to
is equal to R2 plus 2.
R2 plus 2. Very good. So from here you have the value of angle 2 also, E minus R2. See, there was a very huge need to replace 1 and 2. Problem is that you cannot have these 1 and 2 in your final derivations. Now see,
Mm.
look at this B, P, D, this point. Can
Mm.
you see any exterior angle property? Exterior
Yes,
angle,
ma'am.
tell me.
Angle of deviation will be equal to 1 and 2.
Very good. Angle of deviation is equal to 1 plus. So angle 1 plus angle 2 is equal to delta, which is exterior angle property. Now 1 and 2's value we've already got because we have to replace I minus R1 plus 2 is E minus
E minus.
R2. Yes, this is equal to delta. Now let's just simplify it. Let me open up the bracket first. See, I minus R1 plus E minus R2 is equal to delta. Now,
Mm.
I plus E if I take from this side, okay, I plus E
Mm.
from here, and I take, in fact, I take, if I take this is minus R1 minus R2 is equal to delta. Correct?
Yes, ma'am.
From here, if I take this minus sign out, I plus E R1 plus R2.
Yes, ma'am.
What is R1 plus R2?
The one which we found. Angle A.
Very good. This is equal to angle A. So your equation is I plus E minus A is equal to delta, which is I plus E is equal to delta plus. This is the actual equation. This is not minimum. This is the equation for deviation. This is the angle of deviation, not minimum deviation. Okay. Equation for angle of deviation. Fine. Now, these are the symbols. Now, minimum deviation is the case when your angle of incidence is equal to angle of emergence. And both these R1 and R2 are equal to each other. Means these R1 and R2 are equal to each other and I is equal to E. This is the case when you will get the minimum value of deviation. These are the two conditions. Okay, R1 plus R2 is equal to A. And here we can say simply 2R is equal to A, R is equal to A by 2. Can we say this?
Yes, ma'am.
From this equation, can we say delta is 2I minus A? From here, we can say two I is equal to delta plus A. I is equal to delta plus A divided by 2. Can I say this?
Yes, ma'am.
These two you have to remember. Besides, the main question that comes from this is to calculate the refractive index. What you have to do, nothing new, apply the Snell's law. What was the Snell's law? Now you tell me.
N1 into sin I is equal to N2 into sin R.
That's correct. Basically, Snell's law that we studied was sin I by sin R is equal to the refractive index. Now, N2 I'm not writing in the denominator because that's 1, the refractive index. Now, will be very easy. This is the case of minimum deviation. I'll just put an M also here. So, this is the minimum deviation. Sin I we've already calculated delta M plus A by 2. Sin I by sin R. R is A by 2.
Right.
This is the formula for the minimum deviation, where N is the refractive index. This derivation is also means it's equally important as the numericals are important from this. Means numericals are also important. This is also very important. It is important, this equation. You should remember it properly.
Yes, ma'am.
Clear? Am I clear?
Yes, ma'am.
Okay. Please write down all these things. This don't.
Okay, ma'am.
This you can. Don't draw this one.
Yes, ma'am. Can you scroll down? Can you scroll down? Ma'am, I'm done. Done, ma'am.
See, this question says calculate refractive index of a material of an equilateral prism. Equilateral prism is that prism. See, if you have equilateral prism is 6 prism. Just a second. Okay, see the angle of the prism is 60 degree. When you have the equilateral prism, angle of the prism is 60 degree. All the angles are 60. And it says for which angle of minimum deviation is also 60 degree. This is also 60 given. And you have to calculate the value of R. You have to calculate the value of the end. So refractive index is equal to sine delta m plus a by 2 sine r by 2. Okay. So minimum deviation is given as 60 degree. That says calculate refractive index of a material of equilateral prism for which angle of minimum deviation is given. Angle A is given to you. Now, what you already know, R is equal to A by 2. Oh, sorry, I have written here R. This is A by 2. So you have A, you have R. So how will we be able to calculate it? See, sine 60 plus 60, both are given, by 2 divided by sine 60 by 2. So this is 120 by 2, that is sine 60 degree divided by sine 30 degree. So n will be equal to sine 60 is root 3 by 2 and sine 30 is 1 by 2. So refractive index is root 3. Okay,
Hmm.
right?
Good, ma'am.
Okay, see, this says that a ray of light passes through an equilateral prism such that I is equal to E. If E is equal to 3 by 4 of A. So angle of deviation has to be calculated. Refractive index of prism has to be calculated. Now I is equal to E. E is given as 3 by 4 of A. Now it is mentioned it is equilateral prism. A will be equal to 60 degree. So emergence will be 3 by 4 into 60. Got it?
Yes,
And
ma'am.
the prism is given. It's like just treat it like the normal uh, equilateral triangle. Yes?
Okay, ma'am. Yes, ma'am.
Have the normal usual equilateral triangle, what you do? You take all the angles to be
60.
60 degrees. So here we can calculate the value. This will be 15, 15 and 3, 45. So this is 45 degree. I is also equal to 45 degrees. It says angle of deviation, but it didn't say angle of minimum deviation. So what do we have to calculate? This is equal to I plus E minus A. But yes, if you see here, this is E and I are given equal. So you have the same equation, 2I minus A. That is 2 into 45 degree minus 60 degree. That is 90 degree minus 60 degree, which is 30 degrees.
30.
Degree is the angle of minimum deviation, angle of deviation, sorry. Now for refractive index, you can calculate the minimum deviation. N is equal to sine del plus A by 2 by sine A by 2. So this is sine delta is 30. Huh?
90 by 6.
Yes, yes, 90. 90 by 2. This will be sine 60 by. So eventually you have this is 90 by 2 sine 45 degree by this is sine 30 degree. Sine 45 is 1 by root 2 and sine 30 is 1 by 2. So 2 by root 2 basically. So you rationalize it. This will be root 2. 2 gets cancelled. Clear?
Yes, ma'am.
Are you understanding this whole concept?
Yes, ma'am.
Okay, write down this question then.
Can you scroll down? Done, ma'am.
Okay. So the rest of the questions I'm not practicing today. This we'll do it in the next class. I want to discuss one or two things with you for your exam, because now we don't have any class then, and 7th is the exam. See, deviation prism of small angle. Small angle, what's the difference? I'll just tell you here. It's that, see, sine I and sine R, they can almost be written as I and R. So E is written as NR1 and I is written as NR1 and E is written as NR2 because small angles are there. Now, small angle prism means angle of prism is very small. The inclination is very small. So when you put the values in the formula, this is the formula, no? Delta is equal to I plus E minus A. NR1 plus NR2
Yes,
minus,
ma'am.
and you take common the refractive index of glass, R1 plus R2 minus A. R1 plus R2 is equal to A.
Yes, ma'am.
So here this becomes A minus A. You take A common, delta, the angle of deviation becomes A n minus 1. This is the angle of deviation. Clear? Delta is equal
Yes,
to
ma'am.
n minus. This is it. This was one thing that I wanted to tell you because this is used. One is Cauchy's formula. Remember here, just remember the refractive index is inversely proportional to the wavelength. Okay.
Okay.
So
Okay,
wavelength
ma'am.
of light will be given to you, in which the red has the highest wavelength. Remember EM waves chapter. So that your part will.
Yes, ma'am.
His formula basically involves this angular dispersion and all. Dispersive power. Now this is all about the dispersion. Just do one thing. You write down this one, deviation through small angle prism. Let me see. Tomorrow are you available for half an hour class or half an hour class is needed? Half an hour, 45 minutes.
Yes, ma'am.
You there? Then this chapter let's
Yes,
complete.
ma'am.
Yeah, because this dispersion part is left, but a very small portion is left, but that will require. Now I'll take your class tomorrow morning. Okay. I hope
Ma'am,
you're
which time? Yes, ma'am. I have a
there.
class from 8 to 9:30. Other than that, I'm free.
8 to 9:30 a.m. Your UA timings.
UAE time. Yes, ma'am.
Okay, so after that I'll take. You will get the reminder. I hope you will be free. I
Yes,
think
ma'am. Yes,
probably,
ma'am.
yeah, okay. Because some students are there who have their morning class, means they have the evening school. So their morning classes will be taken, and after that I'll just have to talk to the students for the time. That's why I'm not
Okay,
sharing the
ma'am.
complete time, but I'll just take 1 hour class maximum. Okay, maximum.
Okay, ma'am.